Hello, everyone, and welcome to Scrambled. Today, I'm joined by Oskar van Deventer, one of the most inventive designers in the world. Oscar is perhaps best known for breaking the world record and designing the 17 by 17 by 17 Rubik's Cube, a marvel that pushed the boundaries of puzzle engineering. But his work extends far beyond just twisty puzzles. He's also designed hundreds of mind-bending mechanical puzzles that blur the line between art, science, and play. With a background in research and innovation, he brings a unique blend of precision and creativity to everything that he builds. Thank you for joining me today.
Sanjay, yes, and thank you for having me. And yeah, I wish you all the best with your new YouTube channel.
Thank you. So my first question is, what first drew you to the world of puzzle design? And I know you've heard this question before many times, but
Sure.
yeah.
And of course, I have a very smooth answer. I was already interested in puzzles and mazes at a very young age, so I have been drawing mazes myself quite frantically. And at the age of 12, it was May 1978. Um, then my parents gave me the book Puzzles of the World, or actually the Dutch version Spelen met Puzzles, and it showed how to make mechanical puzzles. At that same time, my tech teacher had open shops, so I could use his equipment. And my tech teacher has taught me, well, I made my very first burr, and he has taught me how to precisely measure and cut, etc. So, yeah, I started making puzzles from that book.
Okay.
And by the end of the year, I had made everything in the book. So, what's next? So, that was for me the trigger to start designing myself.
Yeah. So when you design a new puzzle, what comes first? The concept, the mechanism, or the challenge?
Answer D, any and all of the above.
Okay.
So sometimes it's the mathematical concept, um, like my famous Hanayama chain puzzle, where you have three rings that you can swap in order without being able to take it apart.
Wow.
And so for that one, we started with the concept, and I needed to find the mechanism and then the challenge.
Okay.
With mazes, very often you start with the challenge. That is the maze.
Right.
Um, so yeah, it varies from case to case, and sometimes yeah, you find a beautiful mechanism. Either you find it yourself, or I find it on the internet, and I'm thinking, what is it? What puzzle can I make with this mechanism?
Yeah. So some of your puzzles, like the gear cube or the Twistianity, I believe, is that how you say it? Some of them are just as beautiful as they are functional. So how do
Thank
aesthetics
you.
play a role in your design process?
Functionality first.
Okay, yeah,
So
that makes sense.
it's always how do you call this? Shape follows functionality, or well,
Okay,
you know the so the fact that the gear cube looked nice, that was just by accident. So originally, Bram Cohen came up with the concept where he wanted to have the gears at the inside, and I thought, well, let's put the gears at the outside, and I was quite surprised. Well, how funny that looked and how scary, because the first version it had quite sharp gears, so that first version was quite dangerous.
so you worked with cutting edge techniques like 3D printing very early on. So how has technology played a role in designing puzzles for you?
Very much.
Okay.
So my designs have always followed technology. So
Okay.
when my tech teacher taught me how to precisely cut wood, I made a lot of puzzles that were like sticks of wood, because I could buy the sticks of wood in the local wood store, and I did the cutting.
Yeah.
But later, I was also taught how to bend metal and solder metal. So I've made some bent and soldered metal puzzles.
Wow.
And well, I've done a lot in cardboard. Later, a friend of mine introduced me to a special type of polystyrene plastic that could be very easily cut and sanded, and I could achieve much more precision with that material by hand. And at that time, I had very good eyes, so I could make my cuts with several tenths of a millimeter precision,
Wow.
and with sanding, etc. So I have used that material later. Then another friend of mine introduced laser cutting, so I've been
Okay.
using the laser cutter. then a friend of mine, that was George Miller, so Peter Knoppers introduced me to laser cutting. George Miller introduced me to 3D printing. He bought one of those very, very expensive $30,000 3D printers in 2003.
Wow.
And each and every of his 3D prints was like 400 or 500 euro or dollar. And when he had a misprint, like so it's one case he had a 2-day print, and then he had the power outage, and
Oh,
then he had to throw everything away.
wow.
And these cartridges were excessively expensive.
Yeah.
But then in 2008, there was the company Shapeways that introduced me to nylon 3D printing with powder, which has even higher precision
Wow.
and that material. And at the same time, I met Bram Cohen, who introduced me to the world of twisty puzzles. So
Yeah.
then I went on with the twisty puzzles for quite some years. And 5 years ago, yet another friend introduced me to a local home 3D printer brand, Dutchy, and he lent me one sample, and of course I had to buy it, and I bought another one and another one and another one.
Yeah.
So now I can print myself, and I can just order the filament. But getting back to your original question,
Yeah.
yes, every time when there is a new technology, it gives new challenges and it allows new puzzles.
That's great. That's good to hear. So, out of all the puzzles that you've created, is there one or two that hold a very special place?
Yes. Well, of course, you have already mentioned my 17 by
Okay.
17
Yeah.
world record. That was a lot of fun. I also mentioned to you my Hanayama chain puzzle that has
Yeah.
won an award in the International Puzzle Design Competition. But that one, it has been my nemesis. I needed 28 prototypes to get it right. So
Wow.
I made prototypes of the layered cardboard where I cut pieces of cardboard glued onto them, like 3D printing, but then last century 3D printing. So completely cutting and by hand. I
Yeah.
made puzzles with prototypes with the plastic that I mentioned, so precisely cutting. Then I've also made some prototypes with laser cutting, but then using the laser cutting to make the molds for tin casting. So I've made some casting in metal myself. But yeah, that thing, I have a whole box of prototypes just for that puzzle. So that's definitely, together with the 17 by 17, my two main achievements.
Yeah. That's very interesting to hear. So, could you go a little bit into maybe the details of creating the 17 by 17 cube? Like what inspired you to begin, and maybe some of the challenges that you faced, and at the end, some of the recognition that you got for it?
Sure. So as for the 17 by 17, at that time, the biggest Rubik's Cube that was on the market was the V Cube by Panagiotis Verdes. That was a 7 by 7.
Wow.
And for 20 years before, people thought 6 by 6 or 5 by 5 is the biggest that we can go. So it was really an eye changer. And he also patented a concept tool to 11 by 11 by 11.
Wow.
So I thought, well, um, let's go beyond that. Uh, because, yeah, I thought it couldn't be that hard. Well, it was that hard, but nevertheless, so I thought, well, what number should I take? Because I could go to 13 by 13.
Right.
An odd number is always easy because then you have the centers to the core.
Right.
But then I thought, well, 17 by 17, I just like the number. It's like, yeah, it's like 3 and 7. Yeah, those are beautiful prime numbers.
Wow.
So I like the number 17 for some reason. It's binary plus one. It's a prime number. And yeah, so that was when I decided, okay, I'm going for a
Yeah.
17 by 17. And then the question was how to design it. So my first thought was to make a very big core and have very thin pieces uh, around that core and turning. And I made a, how do you call it, a pillow version. And I found Klaus Weniger, he's a German puzzle enthusiast. He wanted to sponsor that. So he sponsored my first prototype and he built it himself. So I have touched it, but I don't own it. He owns it. And it was a miserable failure because all the pieces waggled and they popped out.
Right.
And that from that prototype, I learned that the pieces need to stay upright. So I invented the concept of the floating anchor. That is, you
Wow.
have the pieces that are connected to each other at the top, but they have a very deep pin down, like a tooth or that goes all the way into the jaw of the puzzle, and that makes sure that the piece stays upright, and it also helps with the alignment. And yeah, once I had that concept, the question is how big do I make it? Well, I knew from other puzzles that I couldn't go any smaller than 4 by 4 millimeter for a square. So I took that as a basis. And from there on, it was just once you have the cross section defined, then it's just work. You need to
Wow.
rotate the cross section, you need to intersect them, do the booleans, then a lot of cleaning up, rounding the edges, transforming to meshes, convert cleaning the meshes, uploading all the parts, ordering the parts. And at that time, that's 2010, 2011, just in the winter, Shapeways, now they're bankrupt, but Shapeways, they sponsored the puzzle. So at that time, it was several thousand euros. So they made a donation in kind of several thousand euro. And yeah, they sent me the pieces. And then first I had to count them because they
Wow.
needed to be dyed. So I needed to count them and making sure that I had all the red pieces, all the
Yeah.
white pieces, and I forgot to name them or number them. So it was really by identification. Okay, then I had all the red pieces, etc. I put the red pieces in a red dye bath, the green ones in a green dye bath, etc. So when they were dyed, I needed to sort them again because they were all red, but they were all different. So
Yeah.
lots of sorting and lots of assembling, and yeah, the whole process from receiving all the pieces to assembly took about a week of work.
Wow. Congratulations, by the way, on success.
Yeah, it was a lot of fun.
Yeah, that's good. So I heard you mention Booleans and some like math concepts. Could you talk a little bit more about how math plays a role in creating this puzzle? Because I don't think it's like fully apparent when you just hear about designing a Rubik's Cube. Like
Yeah.
math isn't the first thing that comes to mind, right? So I just want to hear a little more about how that plays a role.
Yeah, well, for solving, obviously, you know that combinatorics
Yeah.
plays a lot of role. Like if you make a turn, what type of permutations can you achieve, etc. But when you're designing a twisty puzzle, what's really the starting point is the cross section. So for a Rubik's cube, the cross section is very simple. You have a piece that goes under the centerpiece, and then that's about it.
Yeah.
And then when you revolve that cross section in one direction, the second and the third direction, then you can cut out the corners, the edges, the centers. And of course, you need to play a bit with the tolerances because when things are tight, they don't fit. So you need to have some space
Yeah.
that they go under. But from there on, it's work. And you asked me about the booleans. So when you have these cutters, so to make a corner, you have a cutter here, a cutter there, and a cutter there,
Yeah.
and you need to boolean intersect them to get the corner piece.
Oh, okay. Interesting. Yeah. So
So it needs to be on this side from this plane, on that side from that plane, and on this side from that plane.
yeah.
Well,
Is there any calculus involved? So my highest
for
math background goes to calculus 3. So I'm just curious if
yeah,
there's any concepts that I know that would be.
well, the answer is yes and no.
Okay.
So the yes part is I'm using 3D software. In my case, I'm using Rhino, but there are many of those, Fusion 360,
Yeah, I've used that
AutoCAD,
one.
etc. So there is a lot of calculus, actually calculus for calculating geometry inside of those programs. However, for me, I don't have to do any calculus. If I want to have a circle, I just say center here,
Yeah.
radius there, and there you are.
That's true.
And
Yeah.
of course, with the sine and cosine, etc., that calculating the circle,
Yeah.
it requires calculus.
Right.
But for me, it's just I'm getting it for free in the software.
Yeah. But you definitely have the knowledge to be able to do it, like if you needed to, right? Without the software. Like, or,
Probably.
yeah.
But I mean, I have the mathematics background, and
Yeah.
for my PhD, I did lots and lots of calculus. But since then, yeah, I never had to do calculus. And anyway, not very difficult types of calculus because, yeah, everything can be automated.
Yeah.
And yeah,
So yeah, speaking about your background, I know you've done a lot of research and work beyond puzzles. So I'm just curious, are there any overlaps between puzzle design, like just how we were talking about, and your scientific engineering background?
well, any functional overlap I try to prevent. So my puzzles are my puzzles, and my work is my work.
Oh,
And I want to keep them separated. Of course, it's a similar part of my brain. I like the creativity. I like coming up with new things. So if you look at my professional things, for instance, if you search my name on patents.google.com, you'll find that I have a few patents.
yeah,
And
I
if you
did too.
look in scholar.google.com, you can see that I have done peer-reviewed articles. But none of those are about puzzles. And when I publish about puzzles, it's just in the magazines for collectors. And of course, well, you know my YouTube channel.
Oh yeah, I have seen that. So I'm just curious, like your puzzles, I know you just mentioned collectors. Have they ever sold for money or have they ever ended up in very distinguished collections by any chance? I'm just curious.
Sure. Well, first of all, there are more than 70 puzzles of mine commercially produced.
Wow.
I already mentioned the Hanayama chain, but for instance, you may recognize the
I,
Hollow
I,
Cube.
I do.
So
Yeah.
you
That's,
let's see whether you can see me through. Yeah, you can
yeah.
see me through in all directions. And this has been mass produced by the Mefferts company. Usually
Wow.
they stay away from 3x3 designs, but this one they wanted to do. So this is one of my productions. This is fairly recent. A bit older is the treasure chest.
Oh,
Um,
I've never
this
seen
is
this.
also a Rubik's cube.
Oh,
So it turns like a Rubik's cube, etc. But when you solve it, it it opens.
wow. That is
And
so
then,
cool.
for instance, I originally designed this for a guy who wanted to propose to his girlfriend, and then she solved the puzzle, and then he took it from her and he opened it and he showed her the ring. Will you marry me? So here was the ring, and here was it. Will you marry me, or something like that.
Wow. That
But
has to be,
anyway, yeah.
yeah, that's the coolest thing I've ever seen. Like, and it has to be solved for you to open it, right? Obviously.
Sorry.
It has to be
Yeah.
solved for you
So
to be able to open.
when it's scrambled like
Yeah.
this, you cannot open it.
Wow.
So you really have to solve it. And of course, since you're a technical person, you know that if the bottom one is scrambled, you can still open it at the top.
Yeah. Yeah.
So
Yeah.
it's only for the top layers. But
Right.
if you
Okay.
look
Yeah.
carefully, you see the little teeth,
Yeah.
and all these teeth are encoded. So if you have
Well,
them in the wrong order, then obviously it does not solve.
I actually want to purchase one. Is it called the treasure chest cube?
This is the treasure chest. Yes.
Okay. I might actually purchase one now. That
Okay.
looks so
Yeah.
cool. Yeah.
You may have it in your collection. I mean, since I have done many puzzles and also many ones that are quite affordable. Yeah,
Yeah.
my puzzles are already in quite a few
Yeah.
collections.
I'm gonna try to see if I can get my hands on one of those. That's super cool. Congrats on
Yeah.
making that. That's so creative and such a good application of the cube. So
Yeah.
yeah. I know you said that your background in Rubik's cubes wasn't as much compared to puzzles, but I mean that is super cool. I did not expect to
Yeah. Yeah.
yeah.
Well, if you look at my YouTube channel, between 2008 and um, 2000, 2020, I think I have produced a twisty puzzle about one per week. So
Wow.
if you look through my YouTube videos from that time, you will find quite a few twisty puzzles.
Yeah. Super cool. So, do
Yeah.
you think your puzzle solving ability, as opposed to designing, but just solving like these kind of puzzles, translates to other kinds of thinking or decision making in other parts of life?
I have no idea, to be honest.
That's
I
fair.
mean, I'm a puzzle enthusiast, and
Yeah.
actually, I'm a designer. So I like to think from concepts that I can turn into something puzzling that is not too easy, not too difficult, and that's just fun to interact with. I
Yeah.
mean, that's my goal in life. And I know that people, for instance, say, yeah, if you do a lot of Sudokus or you play a lot of chess, you will keep your mind young and you will get dementia less.
Yeah.
But I'm not sure. I'm not a specialist in this, and I also don't know whether it works in that direction. That because you're training your mind, you're getting no dementia, or because the people without dementia are better in training their mind.
Right.
So
Yeah.
I don't know. But as I already told you, I'm just a specialist in puzzles.
Yeah.
And what I can tell you is, of course, that what I the part of my brain that likes to solve puzzles or to actually to solve design challenges, those are the same for puzzles and for the stuff at my work.
Wow. Yeah. So what kinds of puzzles are you looking to explore or most excited about in the next few years, if design wise or any kind of work that you're looking forward to?
To be honest, again, I don't know.
Okay.
Whatever comes on my path. So originally, I was not excited about twisty puzzles at all. And then I met Bram Cohen, who came up with a crazy concept like, okay, if you have a triangular prism and you cut them around the corners such that you cut off triangles, and you do that 6 times, then you get a shape with 11 pieces. And I was thinking, wow, this sounds crazy. By the way, let me see
Okay.
whether I can get it
Yeah.
for you quickly, because I think I have it here somewhere. Yeah.
Wow.
So yeah, here we are.
Oh,
So
interesting.
anyway, this is I think around 2008 or so that I walked with Bram at one of our puzzlers events in Gold Coast, Australia. We were walking on the beach. My wife was there as well, and he told me about this concept. And I was really thinking in my mind, like, first of all, what the hell is he talking about? How can it work? Why can it work? And now it's history. So he pulled me into the twisty puzzles with this very nice mechanical design challenge. And you can see it's now being produced by MF8. And
Wow.
if you look for MF8, and I forgot what the thing is called, but anyway, what it does is you see it's a triangular
Yeah.
prism and it's corner turning. And when you turn the corners, for instance, like this, then you can make other
Wow.
shapes. And yeah, this concept that it's shape shifting like this, like crazy,
Yeah.
that is something that Bram calls jumbling. And it's a special geometry thing. If you look at the Twisty Puzzles forum for jumbling, you will find a lot of interesting mathematics behind it. And for instance, it's related to fractals, it's related to the difference between rational and real numbers, etc.
Wow.
So yeah, it was the starting point of something very surprising.
So I wanted to ask you, do you think there's inherent value in students or younger people to try and create their own puzzles? And do you think it's a helpful process for especially students in high school or college to try and make puzzles and work through the challenges? I'm just curious.
Um, I think the answer is yes, but I want to make it more generic. I mean, design a puzzle. And by the way, one of the local high schools, one time they challenged their students exactly to do that.
Oh,
Like
wow. Yeah.
these were like 15 years old, and the challenge was design and prototype a puzzle. And of
Yeah.
course, they asked me for consult, and of course, I tried to be as unhelpful as possible because I don't want to give them any ideas. I want to see their
Yeah.
creativity.
Yeah.
So I think that that type of challenge is, of course, very good, but I'd like to see it more generic.
Okay.
Invent something that is useful. I mean,
Mhm.
that's the challenge.
Yeah.
So go out, go around, and see whether you bump into a silly problem for which you can come up with a solution.
Yeah.
And it could be, of course, a technical solution. I mean, for this one, the challenge was make a Rubik's cube that is completely hollow and that has no core.
Yeah.
So that was the challenge for this.
Yeah.
But this has I mean, find the design a better injection needle. I
Mhm.
mean, injection needles hurt. So can
Yeah.
you design one that achieves its goal without hurting? Well, this is just a random example, and I think it would be very good if at schools um, children are stimulated to find problems. You know, the most important challenge for when you design something, it's not finding the solution, no, it's finding the problem. And you see many things in the world where you think, I could have thought of that. But the person who first thought of that was the first person to recognize the actual problem that needed to be solved. And once you have clearly specified your problem, often the solution is much easier. I mean, once I knew that I wanted to do the 17 by 17 or the hollow cube, yeah, from there on, it was just a matter of design. But finding the problem, defining the problem, yeah, that's the thing that's interesting.
Yeah. That is the first step of the design process, right? If I'm not
Yes,
mistaken. Yeah. That's very,
yeah.
yeah.
And in my office, so I'm a lot involved in patenting.
Yeah.
So for my profession, for many projects, I'm supposed to come up with new things, and
Yeah.
new things means patentable.
Yeah.
And for a patent, the first, or for any invention, the first step is the wish invention. That is a clear specification of the problem that you want to solve. And very often, the creativity and the first inventor is the person who comes up with that problem. Because once you have clearly specified the problem, then yeah, with the group you can solve it. But it starts with identifying the problem.
Yeah. Well, on that powerful note, I think this episode has come to its conclusion. Thank you, Oscar, for joining me and talking about your puzzles. It's really great to hear you speak about your passion and hopefully inspire other people to also try puzzle designing and problem solving that can be useful in the modern world, especially with all the problems we have in society today.
Yeah.
Everyone, if you like this episode, be sure to subscribe, share, leave a comment. Thank you.
Bye, everyone. Thank you, Sanjay.